Imagine this flow, V sub d, imagine this flow of charge, V sub d, there is a current here, and there is a battery that is giving energy per unit of charge. So there is the charge Q here, ddq, that is coming at the velocity v sub d, ddq that is coming at the velocity v sub d. Okay, so the energy, there is a energy per unit of charge the battery gives to pass from here to here. So the energy per unit of charge multiplied by the charge is the energy that gain the charge. So the energy that gain the charge per unit of time is what we call the power, joules per second, or watts, joules per second. And how much it will be in a circuit, how much energy per unit of time the battery have to give to the circuit to maintain the currents. Well, the energy is V sub E by ddq. Divided by ddt is V sub E by I. So this is the power, the energy per unit of time that the battery is giving to the circuit. From here, you can play with this equation V sub E equal I, but I is V sub E divided by R if the conduction takes place in a conductor that is an omniconductor. So the power will be V sub E squared divided by R. And that's all. So you have to imagine something like this. It's like a pump. The battery is working like a pump. It's pumping volumes of charge. Volume of charge is they are pumping and make them to move with constant velocity V sub d, and wherever it goes here, the battery will give you again the energy that they need to go again circulating, to keep circulation, to keep the currents alive. That's all.